DNS stands for Domain Name System. The domain name system is the phone book of the Internet. Humans access information online through domain names like yahoo.com or google.com. Web browsers interact through IP addresses. DNS translate domain names to IP addresses so browsers can load Internet resources. Each device to the Internet has a unique IP address which other machines use to find the device. servers eliminate the need for humans to memorize IP addresses such as 192.168.1.1. Rather, we can just type google.com and we can get the page. Suppose you want to visit the site google.com. You open your browser and type google.com in the address bar and hit enter on the keyboard. Immediately there is a quick check to see if you have visited the site previously. If the DNS records are found in a computer's DNA cache, then rest of the DNS lookup is skipped and you will be taken directly to google.com. If no DNS records are found, then a query is sent to your local DNS server. Typically, this is your internet provider server and is often called as resolving name server. If the DNS records are not cached on the resolving name server, then the request is sent to the root name server to locate the DNS records. Root name server are designated servers around the world that are responsible for storing DNS data and keeping the system working smoothly. Once the DNS record is found on the root name server, it is cached to your computer. Now let's see an example for DNS. In the given picture, there are two devices connected to a switch which in turn is connected to a DNS server. As of now, no IP has been assigned to any of the device, so let's go ahead and assign IP address to each of the device. For PC2, the IP address is 192.168.1.3 with default subnet mask. The gateway will be 192.168.1.1 and the DNS is 192.168.1.2. Similarly for PC3, 192.168.1.4 with default subnet mask, gateway is 168.1.1 and subnet DNS server is 192.168.1.2. Let's go ahead and assign the IP address for DNS server as well. IP address is 192.168.1.2. Default subnet mask, gateway is 168.1.1 and DNS server is the same as the IP address .2. Now if you try to ping from PC2 to PC3 using the host name, it won't be able to go ahead. Ping PC2. As of now, DNS has not been enabled. We have just assigned the IP addresses. Now if you try to ping the IP address of PC2, that is 192.168.1.4, we'll get a good response back. Now let's go ahead and enable the DNS on the server. We go to Services, in DNS tab, select On. For the first, we go for PC2, put in the IP address, that is 192.168.1.3, add. Similarly for PC3, 192.168.1.4, and we'll also add the name of the DNS server. DNS server 192.168.1.2. Okay, and add. Now if you try to ping from PC3 to PC2 using the host name, it will go through as we have enabled the DNS. Ping PC2 and we get a response. So this is how DNS work. DNS basically converts the IP address into the host name. Therefore, we need not memorize the host name. DHCP stands for Dynamic Host Configuration Protocol. It is a network protocol used on IP networks where a DHCP server automatically assigns an IP address and other information to each host on the network so they can communicate efficiently with other endpoints. In addition to the IP address, DHCP also assigns the subnet mask, default gateway address, domain name server address, and other configuration parameters. The primary reason DHCP is needed is to simplify the management of IP addresses on network. No two hosts can have the same IP address, and configuring them manually will likely lead to errors. Even on small network, manually assigning IP address can be confusing, particularly with mobile devices that require IP addresses on a non-permanent basis. Also, most users aren't technically proficient enough to locate the IP address information on a computer and assign it. Automatic, Automating this process makes life easier for users and the network administrators. Components of DHCP. DHCP server. A network device running the DHCP service that holds IP addresses and related configuration information. This is most typically a server or a router, but could be anything that acts as a host, such as an SD-WAN appliance. DHCP client. The endpoint that receives configuration information from a DHCP server. This can be computer, mobile devices, IoT endpoint, or anything else that requires connectivity to the network. Most are configured to receive DHCP information by default. IP address pool. The range of addresses that are available to DHCP clients. Addresses are typically handed out sequentially from lowest to highest. Subnet. IP networks can be partitioned into segments known as subnets. Subnets help keep networks manageable. Lease. The length of time for which a DHCP client holds the IP address information. When a lease expires, the client must renew it. DHCP relay. A router or a host that listens for a client message from broadcast on that network and then forwards them to configured server. The server that sends responses back to the relay agent that passes them along to the client. This can be used to centralize DHCP servers instead of having a server on each subnet. So now let's see an example for DHCP. In the given configuration, there are three PCs connected to a switch, which in turn is connected to a router. If we check the IP address of this PC, no IP address has yet been configured. We'll go to the router and create a DHCP pool for this IP address. Prior to that, we'll assign a gateway IP address to the router. The gateway IP address is 192.168.1.1 with default subnet mask. Now we'll go to the CLI and configure the DHCP pool for the router. The commands are IP DHCP pool. You can give any name to the pool. LAN. We'll give a network of 192.168.1.0 and default subnet mask of 255.255.255.0. We'll give a default router, that is the gateway IP 192.168.1.1 and the DNS server 192.168.1.10. That's it. And then we do write. Now we'll go to the end device, that is a PC, and we'll see if this has been configured correctly. We enable the DHCP and we can here see that the IP address 192.168.1.2 has been given to the PC0 by the router. The default gateway has been also set and the DNS server is also set. For PC1, the IP address would be 1.3. This is because the DHCP assigns IP address on the basis of the smallest to the highest rank. Thank you. ARP stands for Address Resolution Protocol. It is a procedure for mapping a dynamic IP address to a permanent physical machine address. The physical machine address is also known as a media access control or MAC address. The job of the ARP is essentially to translate 32-bit addresses to 48-bit addresses and vice versa. This is necessary because in IP version 4, the most common level of IP in use today, an IP address is 32-bit long, but MAC addresses are 48-bit long. When a new computer joins a LAN, it is assigned a unique IP address to use for identification and communication. When an incoming packet destined for a host machine on a particular LAN arrives at a gateway, the gateway asks the ARP program to find the MAC address that matches the IP address. A table called the ARP cache maintains a record of each IP address and its corresponding MAC address. Now let's see how a network device identifies a packet and forwards it to the respective host. When a packet is generated from internet and it is forwarded to the host, the router checks its ARP table and then forwards the packet to the destined host. In this case, the packet is assigned for 1.1.1. The router checks its ARP table and then forwards this packet to the respective host. Thank you.